Hey everyone, and welcome. Today we're going to break down a classic Leetcode problem that's a great introduction to dynamic programming patterns. It's number 118, Pascal's triangle. Let's dive in. Okay, so the problem asks us to generate a certain number of rows of Pascal's triangle. We're given an integer, which the problem calls numRows, and that tells us how many levels of the triangle to build. The key rule, as the image shows, is that every number in the triangle is the sum of the two numbers directly above it. So our input is just one number, like 5. Our output needs to be a list of lists. For an input of 5, we'd return 5 lists, with each one representing a row of the triangle, just like you see here. The structure is important. It's a list that contains other lists of integers. The best way to understand this is to just build it. Row 1 is always just a 1. Row 2 is always 1, 1. Now it gets interesting. For row 3, the outer numbers are always 1. To get the middle number, we look at the row above it, and we add 1 plus 1, which gives us 2. So we get 1, 2, 1. See the pattern? For row 4, we look at row 3. 1 plus 2 gives us 3. 2 plus 1 gives us another 3. Tack on the ones at the ends, and we have our row. We just keep repeating this process. Let's think about the simplest case. If the input for numRows is just 1, what's the output? Well, it's just the very first row of the triangle. So we return a list that contains a single list, with the number 1 inside. The constraints tell us we'll always get at least 1, so we don't need to handle 0 or negative inputs, which is nice. So the strategy here becomes pretty clear. We can see that to build any row, all we need is the row that came right before it. This is a huge clue. It means we can solve this iteratively. We'll start with the first row, and then in a loop we'll calculate the second row, then use the second to get the third, and so on, until we've built all the rows we need. Alright, here's the full Python code that implements our row-by-row strategy. Don't worry if it looks a bit complex at first glance. We're going to break down each part on the next few slides so it's crystal clear. First things first, we initialize our result. Although the problem says numRows will be at least 1, it's good defensive programming to check for 0. If it is 0, we just return an empty list. Otherwise, we create our main list, which we'll call triangle, and we seed it with the very first row, which is always a list containing just the number 1. Next up is our main loop. We need to generate all the rows after the first one. So if we need 5 rows in total, and we already have 1, this loop needs to run 4 more times. That's why it goes from 0 up to numRows minus 1. This loop will control the creation of each new row. This is the heart of the algorithm. Inside our main loop, first we grab the most recent row we added to our triangle list. Let's call that previous row. Then we start building our new row, and every new row begins with a 1. Next, a small inner loop walks through the previous row. It adds up adjacent numbers, the element at j and the one right after it at j plus 1, and appends that sum to our new row. After that inner loop finishes, we know the middle part is done. We just need to add the final one to the end of the new row, and voila, we've built a complete new row, so we add it to our main triangle list. This whole process repeats until we have all the rows we need. So what's the performance like? For time complexity, we have to calculate every single value in the triangle. The total number of values is proportional to numRows squared. So we get a time complexity of big O, of numRows squared. And since we have to store that entire triangle in our result list, the space complexity is the same. Big O of numRows squared. Let's recap the main points. The best way to solve this is with an iterative row-by-row approach. The most important realization is that any given row only depends on the one right before it. Once you see that pattern, that each row is just a 1, followed by the sums of pairs from the previous row, and then another one, the logic for the code falls right into place. And that's Pascal's triangle. I hope this breakdown made the solution clear and easy to understand. If it helped you out, please hit that like button, and consider subscribing for more Leetcode explanations. If you have any questions or a different way of solving it, drop a comment below. And of course, the Boba Fund is always appreciated. Keep on coding, and I'll see you in the next one.